Lieutenant Commander Takeshi Matsumura pressed his face against the rubber eyepiece of the periscope, his hands gripping the handles with practiced firmness as submarine FARS 36 maintained its silent vigil beneath the surface. The morning sun cast long shadows across the American anchorage, and what he witnessed through that narrow circle of magnified vision would fundamentally alter his understanding of the war Japan was fighting. His first glance revealed the expected concentration of warships, the grey hulls of destroyers, cruisers, and carriers arranged in defensive patterns across the lagoon. But as he swept the periscope slowly from north to south, methodically cataloguing each vessel for his report, he noticed something that made him pause and request verification from his navigation officer. Floating in the calm waters were 6 enormous structures, unlike anything in his experience or training. They were not ships in the conventional sense, lacking the sleek lines of warships or the utilitarian bulk of cargo vessels. Instead, they appeared as massive rectangular platforms, their sides rising like steel cliffs from the water. Each structure dwarfed the destroyers moored nearby, and one held something that made Matsumura's breath catch in his throat. The battleship USS Alabama sat completely out of the water, her entire hull exposed to the tropical air, suspended above the ocean's surface as though lifted by invisible hands. Her massive propellers hung motionless in space, and across every visible surface swarmed hundreds of workers, their welding torches creating sparkles of light that reminded him incongruously of fireflies on a summer evening in Nagasaki. He called his executive officer to the periscope, needing confirmation that what he observed was real and not some trick of light or fatigue-induced hallucination. Commander Hiroshi Tanaka took his turn at the eyepiece, spending several minutes in silence before stepping back with an expression of profound concern. "They had brought their shipyards with them," Tanaka said quietly. "The Americans have brought their entire industrial homeland to our waters." Matsumura spent the next 4 hours at periscope depth, risking detection to document what he witnessed. His notebook, a small leather-bound volume he kept in his breast pocket, filled with sketches and calculations. He drew rough diagrams of the floating structures, noted their dimensions as best he could estimate, counted the number of workers visible on each platform, and recorded the types of ships under repair. Another structure held 2 cruisers simultaneously, both lifted clear of the water, both covered in scaffolding and repair crews. A third appeared to be a floating machine shop, its sides lined with what looked like industrial equipment, smoke rising from multiple stacks. The implications cascaded through his mind as he watched. Every calculation the Imperial Naval General Staff had made about American repair capabilities was fundamentally wrong. The premise had been simple: damage enough American ships and they would be forced to withdraw thousands of miles to their home shipyards, removing them from combat for months. The journey alone, crossing the vast Pacific to reach California or Washington, would consume weeks. Add repair time, and a damaged ship might be unavailable for half a year. This strategy had formed the mathematical foundation of Japan's war planning, but the Americans had simply eliminated distance from the equation. They had manufactured their shipyards in sections, towed them across the greatest ocean on Earth, and assembled them at the front lines. Ships damaged in battle could be repaired within sight of the combat zone, returned to action in weeks instead of months. The multiplication effect on American naval power was staggering. That night, after I-36 had withdrawn to safe distance and surfaced under cover of darkness, Matsumura composed his coded report by the dim red light of the communications room. He chose his words carefully, knowing they would be read by admirals and planning officers who had spent lifetimes studying naval warfare. "They repair ships faster than our kamikaze can damage them," he wrote. "This is not war as we conceived it. This is mathematics we cannot win. The enemy has brought the industrial power of their mainland to our doorstep. We are not fighting a navy. We are fighting an entire nation made mobile." The structures Lieutenant Commander Matsumura had observed were auxiliary floating dry docks, designated AFDB in American naval terminology. Each represented a triumph of engineering ambition over conventional thinking. AFDB-2, the largest he had seen, stretched 927 feet from end to end, longer than 3 football fields laid end to end. It displaced 90,000 tons when fully ballasted, possessed a lifting capacity that could raise even the mightiest battleships clear of the ocean, and operated with a permanent crew of 600 highly trained personnel. Within its steel walls existed complete machine shops equipped with lathes, milling machines, and precision tools. Foundries could cast replacement parts from raw metal. Electrical repair facilities could rewire entire ship systems. Storage tanks held 65,000 gallons of fuel oil. The dock generated its own electricity through diesel generators, distilled fresh water from seawater using evaporators, and functioned with the efficiency and capability of any major naval shipyard on the American mainland. What Lieutenant Commander Matsumura could not observe from his submerged position, what no amount of periscope surveillance could reveal, was the true scale of what the Americans had achieved. Scattered across the vast Pacific theatre were 7 major advanced base sectional docks and 31 smaller auxiliary floating docks, plus dozens of additional repair vessels and facilities. The Americans had systematically transformed every captured atoll, every secured island, every established anchorage into a potential equivalent of Pearl Harbor. Geography had ceased to be a limiting factor in American naval operations. 3 weeks before the attack on Pearl Harbor, in the austere conference room of the Japanese Naval General Staff Headquarters in Tokyo, Vice Admiral Osami Nagano had presented the final operational plans to a gathering of senior officers. The room held the collective experience of decades of naval warfare, men who had studied at the finest academies, who had absorbed the lessons of history from Trafalgar to Tsushima. The calculations they reviewed that day seemed flawless, built on solid intelligence and reasonable assumptions about American industrial capacity and geographical limitations. America possessed 8 major naval shipyards distributed along the Pacific coast. Mare Island in California could handle 4 capital ships simultaneously in its dry docks. Puget Sound Naval Shipyard in Washington State could manage 3. Pearl Harbor, the closest facility to the anticipated war zone, could accommodate perhaps 6 major repairs at once if all facilities operated at capacity. Smaller yards at Long Beach, San Diego, and San Francisco added additional but limited capacity. The mathematics, viewed through the lens of conventional naval warfare, appeared favorable to Japanese strategic objectives. If Japanese naval and air forces could damage or sink 20 American capital ships during the first 6 months of conflict, the staffers calculated it would require the Americans at least 18 months to complete repairs and return these vessels to combat readiness. The distances involved magnified every advantage. A battleship damaged in the waters around the Philippines would need to steam more than 3,000 miles to reach the nearest major repair facility on the Pacific coast. The journey alone consumed 2 weeks each way, assuming the damaged vessel could maintain reasonable speed. Add time for repairs, which for major battle damage might require 3 to 6 months, and the mathematics suggested a damaged ship would be removed from active service for at least half a year, possibly much longer. Admiral Isoroku Yamamoto, despite his personal reservations about initiating war with the United States, had examined these estimates and found them credible. His operations officer, Commander Kameto Kuroshima, had assembled comprehensive charts and analyses of American industrial capacity. The raw numbers were intimidating. The United States had produced 1.5 million tons of merchant shipping in 1941. Japan, by comparison, had produced 400,000 tons. The disparity in raw industrial output was obvious and concerning. But Kuroshima argued convincingly that naval construction operated under different constraints than merchant ship production. Warships required specialized facilities that could not be quickly replicated. They demanded skilled workers with years of training in complex trades. They consumed specific materials and components that existed in limited supply. Most critically, they needed dry dock space, and dry docks were permanent installations carved from granite and concrete, built over years or decades. The bottleneck in American naval repair would not be raw industrial power or material resources, Kuroshima insisted, but the fixed number of dry dock facilities and the immutable distances of Pacific geography. The planning staff had not imagined, could not have imagined within the framework of their experience and training, that Americans would simply build new shipyards and float them to the battle zone. The technological foundation of American floating dry docks traced back to commercial maritime needs. In 1927, the United States Navy had commissioned its first significant self-propelled floating dry dock, designated YFD-2. The concept departed radically from traditional dry dock design. Instead of excavating massive basins from solid ground and constructing permanent granite walls, floating dry docks operated on elegantly simple ballast principles borrowed from submarine technology. The dock consisted of a U-shaped steel structure divided into multiple watertight compartments. To submerge the dock, operators flooded these compartments with seawater, increasing the structure's weight until it sank below the surface. A damaged ship could then maneuver into position over the submerged dock. When pumps expelled the water from the ballast compartments, the dock rose, lifting the vessel completely clear of the ocean, exposing its hull for repairs. By 1940, as war clouds gathered over both Atlantic and Pacific, American naval planners recognized that this floating dock technology, if massively scaled and made truly mobile, could fundamentally alter the strategic geography of naval warfare. The Bureau of Ships, working with forward-thinking officers who understood industrial logistics, initiated a program that seemed impossible even to experienced American marine engineers. The specifications were audacious. Build floating dry docks large enough to handle battleships displacing 45,000 tons. Design them in sections that could be manufactured at different shipyards, towed separately across oceans, and assembled at remote locations. Ensure they could operate independently without support from shore facilities. The Advanced Base Sectional Dock Program represented American industrial organization operating at its most ambitious scale. Each complete dock would consist of multiple sections manufactured at different locations across the United States. Section A might be built at Everett Pacific Shipbuilding in Washington State. Sections B and C could come from Chicago Bridge and Iron Company facilities in California. Sections D through G might be fabricated at Mare Island Naval Shipyard. Each individual section weighed 3,850 tons and measured 93 feet in length, 165 feet in width, and 75 feet in depth. When 10 sections were welded together at their final destination, they would create a floating dock capable of lifting an Iowa-class battleship entirely out of the ocean. The engineering challenges appeared insurmountable to conventional thinking. Each section needed sufficient structural strength to withstand Pacific storms during the long towing voyage from American shipyards to combat zones thousands of miles distant. Yet the sections also required precision manufacturing to tolerances measured in millimeters, because once they reached their destination, they would be welded together to form a unified structure. If the bolt holes did not align perfectly, if the mating surfaces were even slightly warped, the entire assembly would fail. The ballast systems presented another layer of complexity. Each section contained multiple compartments that needed to fill and empty in perfect synchronization. If one section pumped out its ballast faster than its neighbors, the entire dock would tilt unevenly, potentially causing catastrophic structural failure and dropping a battleship worth tens of millions of dollars into the ocean. The pumping systems required redundancy, precision controls, and fail-safe mechanisms that would function reliably in tropical heat, saltwater corrosion, and potential combat conditions. Beyond the basic lifting function, these floating dry docks needed to be self-sufficient industrial facilities. They required complete machine shops capable of manufacturing virtually any replacement part a damaged ship might need, from propeller shafts 15 feet long to precision gun barrels. They needed electrical generating capacity to power tools, lights, and life support systems for crews numbering in the hundreds. They required food storage, fresh water production, sleeping quarters, medical facilities, and all the infrastructure necessary to support complex industrial operations thousands of miles from any mainland support. Commander Tamachi Hara, captain of the destroyer Shigura, one of the few Japanese destroyers to survive the entire war, witnessed the practical impact of American mobile repair capability during the naval battles around Guadalcanal in early 1943. His ship had engaged American forces near Tulagi in March of that year, and during the engagement his torpedomen had scored what they believed was a decisive hit on the heavy cruiser USS Helena. The torpedo had struck near the bow, and through his binoculars Hara had seen the explosion, the gout of flame and water, the visible list as the cruiser took on water and turned away from the battle. Japanese naval intelligence, operating on conventional assumptions about repair timelines, had reported that Helena would require a minimum of 6 months in a stationary dry dock for proper repairs. The damage had been substantial, the distance to American repair facilities was vast, and standard doctrine suggested the cruiser was effectively removed from combat operations for the foreseeable future. Hara's staff had marked Helena as unavailable in their order of battle calculations. 3 weeks later, aerial reconnaissance photographs landed on Hara's desk, showing Helena at Tulagi, fully operational, her guns firing at Japanese aircraft attempting to attack American positions. The intelligence officers were baffled. Where was the dry dock? They asked each other. The photographs showed only empty ocean, small islands with minimal facilities, and the anchorage itself. There was no visible dry dock infrastructure, no massive granite walls, no permanent repair facilities. Yet Helena was clearly repaired and fighting. What Commander Hara and Japanese intelligence officers could not see in their aerial photographs was ABS-D1, assembled at Espiritu Santo just weeks earlier. The massive floating structure had submerged its deck, allowing Helena to position herself precisely over the keel blocks. In less than 4 hours, powerful electric pumps had expelled 8 million gallons of seawater, raising the 10,000-ton cruiser completely out of the ocean. Repair crews had then worked around the clock for 19 consecutive days, welding new steel plates over the 20-foot gash in Helena's bow, replacing damaged frames and bulkheads, testing and repairing electrical systems damaged by the torpedo's shockwave, and restoring the ship to full combat capability. The same repair at Yokosuka Naval Arsenal, Japan's premier shipyard facility, would have required 4 months under optimal conditions. Captain Hara's confusion reflected a fundamental conceptual gap that plagued Japanese naval planning throughout the war. Japanese officers conceived of naval bases as fixed installations, permanent facilities built over decades through sustained investment. Yokosuka Naval Arsenal, Japan's most capable facility, had been under continuous construction and expansion since 1866. The massive dry docks were carved from living rock. The machine shops had been equipped over generations. The skilled workforce represented decades of training and accumulated expertise. This was the mental model Japanese planners applied when calculating American repair capabilities. The Americans had created equivalent industrial capability in 6 months and made it float. They had loaded it onto ocean-going tugs and towed it to the front lines. They had transformed fundamental assumptions about the relationship between geography and naval power. Admiral Chester Nimitz, commander of Pacific Fleet, understood with remarkable clarity how floating dry docks transformed the basic arithmetic of attrition warfare. In a detailed memorandum to Admiral Ernest King, Chief of Naval Operations in Washington, dated January 15, 1943, Nimitz articulated the strategic implications with precision. The availability of floating dry docks in forward areas fundamentally alters the correlation of forces, he wrote. A damaged ship repaired in 3 weeks at Ulithi versus 3 months in San Francisco represents not merely a time savings, but a 4-fold increase in effective available force strength. The mathematics of fleet concentration and availability change completely when repair time contracts by 75%. The Japanese High Command discovered this new strategic reality gradually, through a series of encounters that contradicted their intelligence estimates with increasing frequency. The Battle of Santa Cruz in October 1942 had been a tactical victory for Japanese forces, damaging multiple American ships, including the aircraft carrier USS Enterprise. The Enterprise had taken bomb hits that destroyed her forward elevator, damaged her flight deck, and killed dozens of crew members. Japanese naval intelligence, applying standard repair time estimates based on their own experience, calculated that Enterprise would require a minimum of 6 months in a major shipyard. They marked her as unavailable in their order of battle and planned subsequent operations accordingly. Enterprise reappeared in combat operations just 30 days later, her flight deck repaired, her elevators operational, her air group flying missions against Japanese positions. The repairs had been accomplished at New Caledonia by the destroyer tender USS Vestal, working in conjunction with advanced base facilities that included mobile repair equipment, portable machine shops, and teams of specialists who had practiced rapid battle damage repair. Rear Admiral Motomi Ugaki, Chief of Staff to Admiral Yamamoto, recorded his bewilderment in his personal diary. "The enemy's repair capabilities exceed our intelligence estimates by factors we cannot explain," he wrote. "Ships we confirm as severely damaged return to battle before our own lightly damaged vessels complete repairs at home facilities. Something fundamental in our understanding must be wrong." By early 1943, the United States Navy had deployed a comprehensive network of floating repair facilities that transformed the entire Pacific Theater into an integrated industrial system. Advanced base sectional docks operated at Espiritu Santo in the New Hebrides, at Ulithi Atoll in the Caroline Islands, at Leyte Gulf in the Philippines, and at Manus Island in the Admiralty Islands. Smaller auxiliary floating docks serviced destroyers and submarines at dozens of additional locations scattered across captured islands and secured anchorages. Each location functioned as a node in a vast repair network capable of handling everything from minor maintenance to major battle damage. The construction statistics, when Japanese intelligence officers finally compiled them after the war, revealed the hopeless nature of their strategic position. Mare Island Naval Shipyard in California had simultaneously produced multiple ABSD sections while continuing to build new destroyers, cruisers, and submarines. The shipyard employed 46,000 workers, organized into 3 shifts operating 24 hours every day. In 18 months, Mare Island alone produced more floating dry dock capacity than existed in Japan's entire permanent dry dock infrastructure accumulated over 80 years of naval development. Lieutenant Commander Haruki Iki, a naval architect assigned to Yokosuka Arsenal, conducted a detailed analysis of American mobile repair capabilities in early 1944. His report, which circulated among senior officers and prompted considerable discussion in planning meetings, calculated that American floating dry docks deployed across the Pacific could simultaneously handle repairs on 18 capital ships, 36 cruisers, and over 100 destroyers and smaller vessels. By comparison, Japan's entire domestic repair capacity, including every dry dock and repair facility from Kure to Yokosuka to Sasebo, could accommodate 6 capital ships, 12 cruisers, and 40 destroyers when operating at absolute maximum capacity. More critically, Lieutenant Commander Iki identified what he termed the multiplication effect of forward repair. A ship damaged in combat near Leyte Gulf and repaired at Ulithi Atoll returned to combat operations in 1/4 the time required for a ship forced to sail to Japan for repairs. The time savings translated directly into combat power. 4 ships operating a forward repair cycle provided the sustained combat presence of 16 ships operating from home facilities. His conclusion was stark and disturbing. "We are fighting an enemy who brings his homeland industrial capacity to the battlefield," he wrote. "We cannot sink ships faster than they repair them. Time and distance, which we counted as allies in our planning, have become irrelevant. The American fleet regenerates itself like a living organism. The floating dry docks achieved their first truly spectacular demonstration during the American invasion of Kwajalein Atoll in February 1944. The battleship USS Maryland, providing fire support for the landing forces, took multiple kamikaze hits that tore a 40-foot hole through her armoured deck and caused extensive internal damage. Traditional naval doctrine, the accumulated wisdom of centuries of maritime warfare, dictated that Maryland should withdraw to Pearl Harbor for repairs, a journey that would consume weeks in transit and months in the shipyard, effectively removing her from combat operations for a substantial portion of 1944. Instead, Maryland sailed 240 miles to Majuro Atoll, where AFDB-2 waited with her crew of 600 specialists. The massive dock, under the command of Commander Joseph J. Rochefort, the name coincidentally shared with the famous intelligence officer who had broken Japanese naval codes before Midway, though they were different officers, submerged its deck through carefully coordinated ballast operations. Maryland maneuvered slowly into position, guided by small boats and precision navigation, until she sat directly over the keel blocks that would support her 45,000-ton displacement. In 4 hours of continuous pumping, coordinated with split-second timing across all sections, powerful electric pumps expelled 8 million gallons of water from the ballast tanks, raising the massive battleship completely clear of the ocean. Her propellers hung motionless in the air. Her entire underwater hull stood exposed to the tropical sun. Captain Yoshitake Miwa, commanding the submarine Fafe 184 on patrol in the area, observed this operation through his periscope from a distance of 8,000 meters. He radioed a detailed report to Tokyo. Maryland entering floating dock at Majuro, he transmitted. Extensive damage visible to upper works. Estimate minimum 3 months repair time based on damage assessment. Recommend strike missions be planned against other units as Maryland unavailable for extended period. 3 weeks later, Maryland departed Majuro under her own power, her crew at full combat stations, her damage completely repaired, her guns ready for action. Captain Miwa, monitoring American radio traffic and comparing voice patterns, realized with shock that the battleship he had observed entering repair was now operational again. He transmitted an addendum to his earlier report. Maryland operational again after 3 weeks. Previous repair estimate completely wrong. The Americans have made time and distance irrelevant to naval operations. Commander Mochitsura Hashimoto, captain of submarine Dwayne 58, which would later sink the cruiser USS Indianapolis in one of the war's tragic final actions, summarized the Japanese perspective in his post-war writings. We would successfully attack an American carrier or battleship, calculate the months needed for repair based on our own experience and capabilities. Develop operational plans that assumed that vessel's absence, only to encounter the same ship weeks later operating at full combat capability, he wrote. It was like fighting mythical creatures from ancient legends that possessed the power to heal their wounds instantly. Our attacks succeeded tactically but failed strategically because the Americans possessed repair capabilities we could neither match nor comprehend. AFDB-7, operating at Leyte Gulf in the Philippines, demonstrated the complete overhaul capability these floating facilities possessed when the aircraft carrier USS Franklin limped into the anchorage after devastating kamikaze damage in March 1945. Franklin had suffered perhaps the most severe damage of any American aircraft carrier to survive the war. Multiple kamikaze aircraft had crashed into her flight deck, penetrated to the hangar bays, and triggered massive explosions among armed and fueled aircraft. 807 sailors had died in the inferno. The ship had nearly capsized, saved only by heroic damage control efforts. Standard peacetime procedure would have classified Franklin as a constructive total loss, suitable only for scrapping. But AFDB-7's crew of 1,000 specialists, working under combat conditions with Japanese artillery still within range of the anchorage, essentially rebuilt the carrier from the inside out. Master Chief Petty Officer William Delaney, who supervised hull repair operations, later testified before a congressional committee about the work. In a stationary yard with full facilities and no time pressure, Franklin's repairs would have been a 6-month job minimum, he stated. We accomplished it in 11 weeks while operating in a combat zone under intermittent enemy fire. His voice conveyed quiet pride in the achievement. Lieutenant Commander Sadao Kusaka flew long-range reconnaissance missions over American advance bases in his specially modified bomber. His April 1944 mission over Ulithi Atoll produced photographs and observations that shocked Japanese naval intelligence when his report was circulated. Observed Ulithi anchorage in detail, he wrote in his formal mission report, counted 6 large floating structures previously identified as possible auxiliary cargo vessels or damaged ships awaiting salvage. Upon closer examination through binoculars and careful photographic analysis, these structures are clearly mobile dry docks. One contains battleship-class vessel, possibly Iowa, with entire hull exposed for repair work. Workers visible on scaffolding surrounding hull. American maintenance and repair capacity is not fixed to geographical locations, but mobile and deployable. They bring their industrial bases with them to the combat zone. Admiral Soemu Toyoda, who assumed command of the combined fleet after Admiral Yamamoto's death, received these reports with growing desperation. At a staff meeting in May 1944, attended by senior operations officers and planning staff, he presented the mathematical reality of defeat with brutal honesty. If the Americans can repair their ships 3 times faster than we can repair ours, he explained, we must sink 9 ships for every one we lose just to maintain force parity. This is mathematically impossible given current loss rates. We are not losing to American naval tactics or superior weapons. We are losing to American floating steel and industrial organization made mobile and brought to our waters. Each advanced base sectional dock section included complete living quarters for its permanent crew. The quarters were not luxurious by civilian standards, but far exceeded typical shipboard accommodations. Bunks had real mattresses, not the canvas hammocks common on warships. Galleys had electric stoves and refrigeration. Medical facilities included fully equipped dental chairs, operating rooms with proper lighting and instruments, and pharmaceutical storage. Seaman First Class Robert Leckie, assigned to AFDB-3 at Manus Island, described the surreal quality of daily life in his memoir. We lived thousands of miles from home on this massive steel structure floating in a tropical lagoon, he wrote. We had movie nights twice a week, projecting films on the dock walls using portable equipment. When no ship occupied the dock, we played baseball games on the floor, using the dry dock basin as an improvised stadium. We had our own newspaper, printed weekly, covering news from home and local gossip. We weren't just repairing ships, we were a floating piece of America transported wholesale to the combat zone. The quality of food served on floating dry docks became somewhat legendary among fleet personnel. While combatant ships subsisted on canned spam, powdered eggs, and dehydrated vegetables after weeks at sea, the dry docks maintained large frozen food lockers, fresh bakeries, and even small greenhouse facilities that produced fresh vegetables. AFDB-2 prepared and served 2,000 complete turkey dinners on Thanksgiving Day, 1944, feeding not only its own crew, but the crews of damaged ships under repair. Fresh bread, a luxury in the combat zone, came from the dock's ovens daily. Vice Admiral Takeo Kurita experienced the strategic impact of American mobile repair capability during the complex series of engagements that comprised the Battle of Leyte Gulf in October 1944. His battle plan had been developed on the assumption that damaged American ships would be forced to withdraw from the combat zone for repairs, progressively weakening the invasion force he was attempting to destroy. Instead, damaged vessels sailed short distances to nearby mobile repair facilities and returned within days, sometimes within hours, for minor damage. Kurita's staff watched in frustration as their carefully calculated force ratios failed to materialize. Kurita later wrote in his private papers, "We would successfully damage an American cruiser with torpedo or gunfire. Observe her withdrawing from the battle area, reasonably assume she was eliminated from combat operations for weeks. only to face the same vessel 3 days later operating at apparently full capacity. We were fighting not merely the American fleet, but their entire industrial system, which they had somehow made portable and brought to our doorstep. The most remarkable pre-war feat of American repair capability, though not involving floating dry docks, demonstrated the principles that would govern Pacific War operations. USS Yorktown, severely damaged at the Battle of Coral Sea, arrived at Pearl Harbor on May 27, 1942. Admiral Nimitz, facing the imminent Battle of Midway with insufficient carriers, gave the shipyard workers an impossible deadline. Yorktown entered Dry Dock No. 1 on May 28. 1,400 workers from Pearl Harbor Naval Shipyard labored around the clock, working in shifts that never stopped, sleeping in brief intervals, then returning to their stations. Yorktown sailed on May 30th, just 60 hours later, her flight deck patched, her boilers operational, her aircraft spotted for launch. Japanese intelligence remained utterly convinced Yorktown was still under repair, probably for at least 3 months. When Japanese pilots at Midway reported attacking a third American carrier, where intelligence had positively confirmed only 2 were available, Admiral Chuichi Nagumo's staff initially dismissed the reports as impossible. Lieutenant Joichi Tomonaga, shortly before his death leading an attack, radioed back confused reports. The Americans possess 3 carriers where our intelligence calculated only 2 were possible. How can this be? By mid-1944, the network of American floating dry docks had transformed the Pacific Ocean into what some called an American maintenance highway. Ships damaged at Iwo Jima could be repaired at Ulithi. Vessels hit during the Philippine campaign sailed to Leyte Gulf's floating facilities. Submarines damaged in combat surfaced and headed for the nearest auxiliary dock. The United States Navy operated 37 advanced base sectional docks, 31 auxiliary floating docks, and 55 smaller repair facilities scattered across the theatre. The combined lifting capacity exceeded Japan's entire permanent dry dock infrastructure by a factor of 4. Each ABSD section cost approximately $40 million to design, build, and deploy, equivalent in price to a light cruiser. The expense was enormous, but the strategic return on investment proved incalculable. Rear Admiral Kizo Kimura, captured after the war and interrogated by American naval intelligence officers, offered his perspective. The Americans build floating dry docks the size of city blocks and tow them across the Pacific as casually as if victory was already certain, he said. You were already building the peacetime fleet infrastructure while we were still desperately fighting the war. The outcome was never in doubt once these facilities deployed. Chief Petty Officer Marcus Thompson, a hull repair specialist assigned to AFDB-2, had trained for 18 months at Mare Island Naval Shipyard before deploying overseas. His team of 40 master welders could repair torpedo damage that would have challenged any permanent shipyard in the world. We became artists of destruction repair, Thompson recalled in oral history interviews decades later. Destroyer with her entire bow blown off by a mine? We would fabricate a complete new forward section in 5 days. Cruiser with a gaping hole in her side from a torpedo. We would cut away the damaged section, manufacture new steel plates to precise specifications, weld them in place, then pressure test the entire repair. Most of our work would have taken weeks in a stationary facility. We did it in days because we had no choice and unlimited motivation. The medical facilities integrated into floating dry docks added substantial strategic value beyond simple ship repair. Each major dock included a hospital facility with multiple operating rooms, recovery wards, pharmaceutical storage, and X-ray equipment. Dr. Lawrence Steinberg, Chief Medical Officer assigned to AFDB-1, performed over 200 major surgical procedures during his deployment, treating everything from combat wounds to appendicitis to compound fractures from industrial accidents. The floating docks served as medical centers for their entire operational area, treating personnel from damaged ships, submarines, and even occasional rescued enemy survivors. In November 1944, Submarine Throne 365 received orders representing a fundamental shift in Japanese strategic priorities. Instead of hunting enemy warships, the submarine was directed to penetrate Ulithi Atoll's defences and attack the floating dry docks themselves rather than the ships they serviced. The mission reflected new thinking in Tokyo. Japanese planners had concluded that destroying American repair capacity was more valuable than sinking individual ships that would simply be repaired and returned to service. I-365 was destroyed by depth charges before reaching Ulithi, becoming one of 6 Japanese submarines lost attempting similar missions against floating repair facilities. The only partially successful Japanese attack on floating dry docks occurred on April 22, 1945. Lieutenant Saburo Shimbo and Ensign Chuhei Okubo, flying at 14,000 feet in conditions of broken cloud cover, mistook 2 empty floating dry docks, ABS-D2 and ABS-D4, for aircraft carriers. The massive rectangular shapes, viewed from high altitude through clouds, vaguely resembled carrier flight decks. They dove to attack, scoring hits that damaged ABS-D2's Section G, with a bomb that penetrated the deck and exploded in a ballast compartment. The dock's own crew, working with characteristic American efficiency, completed temporary repairs within 3 days, restoring full operational capability within a week. Permanent repairs were completed over the following month while the dock continued servicing ships. Commander Masataka Okumiya, one of Japan's most thoughtful naval air tacticians, analysed the strategic implications in his extensive post-war writings. We could occasionally damage a warship, could even occasionally damage a floating dry dock itself, but the docks multiplied faster than we could destroy them, he wrote. They were not simply floating facilities, but floating factories that seemed capable of reproducing themselves. Each one represented the entire American industrial system made manifest and mobile. The Okinawa campaign from April through June 1945 witnessed the most concentrated campaign of kamikaze attacks in the war. Over 400 American ships sustained damage of varying severity. A fleet of floating dry docks at Karama Reto, a small island group near Okinawa, operated continuously under combat conditions, sometimes lifting damaged ships while still under intermittent air attack. The docks worked through air raids, their crews taking shelter when alerts sounded, then immediately returning to work when raiders passed. Repair operations never truly stopped. Captain Toshiyuki Yokoi, tasked with coordinating kamikaze operations, recorded his frustration in official reports. Our pilots sacrificed their lives in attacks against American warships, achieving successful hits that would normally remove vessels from combat for months, only to see these same ships returning to the battle line within days, he wrote. The floating dry docks at Karama Reto repair ships faster than we can organize new attack missions. The mathematics of attrition warfare have been fundamentally altered. Of 404 ships damaged during the Okinawa campaign, 387 received sufficient repairs at forward facilities to continue operations without returning to permanent bases in Hawaii or the continental United States. The destroyer USS Laffey, struck by 6 kamikaze aircraft and 4 bombs on April 16th in one of the war's most ferocious individual ship actions, was under repair at Karama Reto within hours and operational again by May 1st, just 15 days after nearly sinking. Captain Minoru Genda, one of Japan's premier naval air tacticians who had helped plan the Pearl Harbor attack, reviewed captured American invasion planning documents after the war. The documents outlined American intentions for Operation Downfall, the planned invasion of the Japanese home islands. They intended to bring 12 major floating dry docks and 40 smaller ones to Japanese waters specifically to support the invasion, Genda noted. Even if we had somehow damaged half their invasion fleet daily through sustained kamikaze and conventional attacks, they could have repaired ships faster than we could reload our guns and organize new missions. The invasion would have been unstoppable. Working with battle-damaged ships in forward areas meant handling countless hazards. Unexploded ordnance lodged in damaged hulls. toxic smoke from smouldering fires, unstable bulkheads that could collapse without warning. On AFDB-3, 7 workers died when a damaged bulkhead aboard cruiser USS Pittsburgh collapsed unexpectedly during repair operations, crushing them before rescue was possible. Yet morale among floating dock crews remained remarkably high throughout the war. The motto of AFDB-2, painted in letters 10 feet high on the dock's side for all to see, read simply, "We keep them fighting." Admiral Soemu Toyoda's post-war interrogation by American naval intelligence officers identified 3 decisive factors in Japan's comprehensive defeat. American submarine warfare that strangled our merchant marine and logistics system, he stated. Your fast carrier task forces that achieved sea and air control, and your floating dry docks that transformed time and distance into irrelevant factors. On this third factor, your floating dry docks killed the Japanese Navy as surely as your bombs and torpedoes, perhaps more so. You made time and distance meaningless. You brought your homeland's industrial power directly to our home waters. We had no counter to this strategic capability. Between 1943 and 1945, American floating dry docks deployed across the Pacific performed 1,847 major ship repairs and 8,234 minor repairs of varying complexity. They returned 95% of all damaged vessels to operational service within 30 days of entering a dock, a repair tempo that would have seemed impossible to pre-war naval planners. Commander Joseph Rochefort, the intelligence officer whose brilliant code-breaking had helped secure American victory at Midway, offered perhaps the most succinct analysis. The Japanese thought they were fighting ships and men and guns, he observed. They were actually fighting our entire industrial system, which we had made portable and deployed to the combat zone. Every floating dry dock represented Detroit's automobile assembly lines and Pittsburgh's steel mills made manifest in welded steel that floated on the ocean. That was an enemy Japan could never defeat because it represented capabilities they could not replicate. The organizational vision came from officers like Rear Admiral Ben Morrell, who commanded the Navy's construction battalions and understood that American industrial superiority meant nothing strategically unless that capability could be projected to the actual point of conflict. His vision and the vision of officers like him transformed raw industrial power from a homeland geographic advantage into a deployed weapon system that could be positioned wherever the fleet needed it. Mare Island Naval Shipyard employed 6,000 women by 1943, roughly 15% of its total workforce. Marjorie Muller, one of the first female welders hired at the facility, worked on ABSD-2's Section F. In interviews decades later, she described the motivation. Every perfect weld meant American sailors would live through battle damage that might otherwise sink their ship, she explained. We understood our work mattered directly to the war effort. The Chicago Bridge and Iron Company employed over 4,000 African-American workers at its California facility, where they constructed 3 complete ABSD sections, achieving production rates that exceeded some integrated shipyards working on similar projects. Admiral Arleigh Burke, who would later become Chief of Naval Operations, frequently cited floating dry docks as the definitive example of American innovation and industrial thinking applied to warfare. The Japanese brought superior training, remarkable tactical excellence, and warrior spirit to the Pacific War, he said in speeches. We brought floating dry docks. They made the ocean a battlefield according to tradition. We made it a factory floor and assembly line. That difference determined the outcome. Japanese naval attachés stationed in the United States throughout the 1930s had faithfully reported on American shipbuilding capacity and techniques, sending detailed reports to Tokyo that were carefully filed and analyzed. But they interpreted what they observed through the lens of their own cultural experience and industrial practices. Commander Yoshiro Fujimura visited Chicago Bridge and Iron Company facilities in 1937 and observed sectional construction methods being used for commercial projects. His report noted Americans build industrial plants like children's toys, manufactured in sections and then assembled on site. An interesting approach, but seemingly irrelevant to serious naval construction, which requires permanent facilities and traditional methods. That fundamental misunderstanding of American industrial philosophy and capabilities would prove catastrophic when war came. As the war ground toward its inevitable conclusion in summer 1945, American floating dry docks were still being produced at accelerating rates. AFDB units numbered 8 through 14 were under active construction at shipyards along both American coasts, intended to support the massive invasion of Japan that never materialized. Engineers were designing even larger units, contemplating facilities that could handle multiple battleships simultaneously. The industrial mobilization showed no signs of slowing even as victory approached. The story these floating dry docks tell extends beyond mere technical capability or industrial statistics. They represent fundamentally different philosophical approaches to power itself. Japan, heir to centuries of martial tradition, conceived of power in traditional terms that emphasized warrior excellence, tactical brilliance, and spiritual determination. Individual skill mattered. Ship handling expertise mattered. Gunnery accuracy mattered. The warrior spirit, what they called Yamato Damashi, mattered above all. These were the currencies of military power as Japan understood them. America conceived of power in radically different industrial terms. Production capacity mattered. Repair capability mattered. Logistics systems mattered. The ability to manufacture, transport, assemble, and operate complex industrial systems in remote locations mattered most of all. The Pacific War tested these competing philosophies comprehensively. Japanese tactical excellence won individual battles. American industrial systems won the war. Once American floating dry docks deployed across the Pacific in force, each one became more than a repair facility. Each represented the entire American industrial system made mobile and projectable. They were Detroit's automobile assembly lines, Pittsburgh's steel mills, and Chicago's machine shops, all compressed into floating steel structures and towed to the battle zone. Against such concentrated industrial might, deployed where it was needed most, no amount of traditional military excellence could ultimately prevail. Admiral Soemu Toyoda's final assessment, delivered during his war crimes trial where he was ultimately acquitted, captured their ultimate historical significance most clearly. "You defeated us the moment your first floating dry docks arrived in Pacific waters," he stated. "We could sink your ships through combat action, but you could raise them again within weeks. You could suffer any level of battle damage and continue fighting without pause." The Pacific Ocean itself became an American lake, not primarily because you controlled its surface through naval supremacy, though you did, but because you could maintain that control anywhere, anytime, indefinitely. We gradually realized we were not fighting ships and aircraft and armed men, but an entire industrial civilization that had learned how to float and brought itself directly to our waters. Against that, we had no answer and no hope of victory.